In this video, we consider some of the nuance of dealing with the domain and range of compositions of functions. So we have this function f, which we're given. We have f of x equals x squared, but we've restricted the domain of f. So we've written here that f sends the domain of -1 to 1. So our inputs are some element of this interval, and our outputs are some real number. Now, you can certainly observe that I'm not going to have the range of this function be the entire real line. It's still perfectly okay to write this r here to indicate that the type of output is a real number. We're a little bit pickier in general about insisting that this domain part is listed as exactly the domain and no extra. But somehow we're a little bit more flexible on allowing this second part here, this codomain, to include more than just the range. So we have f of x is x squared under this restricted domain, and g of x is equal to x minus 1 with no restrictions on the domain whatsoever. We're asked to consider what's going on with f of g of x. So let's draw a picture to start getting our head around this problem. In particular, I want to draw this abstract picture of a composition of functions. So compositions of functions look like this. We start with some x over here, and what's the first function we apply? We first apply g to x, and then we apply f. So we start with x, then we'll spit out g of x, and finally we'll spit out f of g of x. And what we need to make sure is that we choose x's that don't cause any problems. Now, whatever x I choose here isn't going to cause a problem with g. In particular, g's domain is the entire real line, so I don't care what gets to here. What I do care about is making sure that the number that appears here feeding into f is in this interval from -1 to 1. So what I need to make sure of is that I choose x's that behave in such a way that when I subtract 1, I'll get something that's between -1 and 1. It's not so hard to see that the domain should be this. If I plug 0 into this composition, I'll get 0 here turning into -1 here, which is the edge of the allowable inputs of f. And if I start with 2 as my input, I'll end up with 1 feeding into f, which is the other edge of my allowable inputs for f. So here's my domain. And in terms of actually writing a formula, a rule for this composition, we can handle this the way that we always do. We have f of g of x. In other words, we have f of x minus 1. And, well, what does f do? It takes its input and squares it. So we have f of g of x is equal to f of x minus 1 is equal to x minus 1 squared, with the restriction that we're only allowing x to be within the interval from 0 to 2.